Hey, this video has spoilers for Jedi Fallen Order, like literally stuff that happens in the last 5 minutes of the game. This is your warning. So important that I put it before the mouse click. Okay, anyway, you can click now. Dear... Wait, should it be Respawn or LucasArts? I mean, LucasArts plastered their logo everywhere, and honestly, how am I still doing this same intro contrivance for years? Years! I mean, this intro part here where I click the Google Drive thing, Google Drive doesn't even look like that anymore. Google Docs is its own freaking thing. This is what it looks like now. Even worse, this is literally the exact same video file I used back when I started the series, when it was in 720p. This is upscaled. And what is this typing effect? It doesn't even look right. You know, there's an actual typewriter effect in After Effects now. I mean, this is what Matt's intro looks like. Why am I still doing this garbage with the deer whatever and the click and the... But by now it should be like, bam! Bokeh! Kapow! Avatar! The epic score rises in the background, a tear forms in your eyes, the hairs on your skin prickle up, and you realize that it's time to do some science! But honestly, at this point, I've been running an extended Pavlovian experiment on you, conditioning you to watch my videos when you hear the sound of the mouse click, so what are you gonna do? I love Fallen Order in particular. I like how they kinda sidestepped the power creep problem that was always kind of a problem in Star Wars video games. Instead of playing an OP teenager capable of tearing down Star Destroyers, in Fallen Order you play as Cal Kestis, a Padawan who survived Order 66, and you are not a god. Although by the end of the game you may have learned some fancy tricks, a wall run that Respawn is legally obligated to put into their games, and have made making stormtroopers pee their suits a normal day-to-day operation, except for this guy.
You don't scare me.
What legendary last words. After defeating my Hot Topic goth girlfriend in a one-on-one duel, you come face to face with Darth Vader, who really nails home how much of an amateur you are. Vader is on another level. Not only is he the literal, actual chosen one, he's been honing his skills against Jedi, rogue inquisitors, and hot groupies for years, while Cal's been working on a junkyard planet, listening to Mongolian rock music and going through puberty, surrounded by nothing but rust and aliens. You have no chance. Vader wrecks your stuff and gives no midichlorians about wasting time with parries and carefully dodged swipes. In fact, I learned while writing this episode and trying to get some extra footage that the dude will just pop off and snap your neck like it's nothing if you lollygag too long. Dude has absolutely zero chill about hunting Jedi. Your only recourse is to run away because, you know, that's what you do when you're a boy who's hoping to seal the deal with a Dathomiri witch in a sequel so she can restart the Night Sisters clan with strong stock, and you're being chased by a giant monster wielding a vasectomy lance. You get away, but not really, because of course you didn't, and it's all drama, climax, blah blah blah, and then Cal has the bright idea to break the walls of the hallway that you're in, letting water rush in and allowing him to escape, and you're only able to escape because behind you, Darth Vader is holding back the water rushing in with the Force like a mother effing badass. Sure, it's not as spectacular as like a ton of other displays of Force powers, but the more you start to think about all the things that are happening, the more you realize that this may actually be the most impressive canon display of the Force we have seen performed by any character anywhere, point blank, except for maybe hologram Luke's ability to ignore the limitations of the speed of light and the transmission of information. But honestly, Star Wars has pretty much no respect for Albert Einstein as a general rule, so, you know, sorry, buddy. But let's back up, because I can already hear you saying, pushing back water, Austin, really? That's what your video is about? And to that, I say, hell yes! Because with this, we can accurately measure the brute strength of Vader and suss out the limitations of his powers, just like Tarkin on Chandar's Folly. Oh yeah. That's right, I'm that kind of Star Wars nerd. But let's go over why this scene is so impressive to me, and why I think it's not only illuminating, but a fascinating math puzzle. This scene takes place on Fortress Inquisitorius, the headquarters of Emperor Palpatine's Jedi hunting experts, the Inquisitors. Fortress Inquisitorius is huge and built on the water moon Nur. Whatever. Most of it is underwater, deep underwater. How deep? We'll get there. Holding back this water takes all of Vader's concentration, which is why Cal and Seer are able to escape. So we can reasonably assume that pushing back this torrential flood of water is somewhere near the upper limit of Vader's capabilities, especially since he's been shown to have trouble holding back water on Mon Cala. This is hard to do for him, and honestly, probably very few others could even pull anything close to it off. But why is it so difficult? Simple. Water is very heavy. We don't usually think of water as being that big of a deal, but considering water is what makes up most of our mass, and as anybody who's ever been tasked with carrying jugs of water upstairs can attest, it is not light. Under normal gravity, water weighs almost exactly a kilogram per liter, and that can add up really quickly. What's worse is that the fluids under gravity exert pressure due to being pulled down by, the gravity. At sea level, our atmosphere exerts 101.3 kilopascals of pressure on our bodies because the weight of the entire atmosphere in a single column leading all the way up to the exosphere is pressing down on us. We are all little atlases carrying the sky on our shoulders all the time. Thankfully, air isn't very dense, and even a 10,000 kilometer column of the stuff really isn't that heavy. Meanwhile, you know how deep into the ocean you have to go in order to experience an increase of 1 atmosphere of pressure? 10 meters. That's it. Just 1/10,000% of the depth of the entire atmosphere into water, and the pressure rises a bunch. This is the power of water. Now look at how deep the freaking Fortress Inquisitorius is. Look at it! And Vader is just deadlifting this water like it's nothing. Now, this is the formula we need in order to figure out water pressure. It's delightfully simple compared to some other monsters we've used on this show. P equals H rho G, where P is pressure, H is height or depth, rho is density, and G is gravity. This will work for most fluids. Now, first things first. Before we can even start plugging numbers in, we need a ruler because we have some measurements to make. Y'all know the drill. Pixel measurements are the cornerstone that hold this entire YouTube channel together, and in order to do pixel measurements, you need a reliable ruler, and usually I have trouble finding one, but we have an easy one this time. Bam! Vader himself. He's right there, and he has a cannon height, 2.02 meters. Hey, Daddy.
They say there's something in the water.
Anyway, using Vader's height, we can reverse engineer Cal's height. Using this panel here in the BDSM torture dungeon for reference, we can determine Cal's model height to be about 1.77 meters. Now that we know his height, we can find our first number, gravity. Sure, we can assume the standard 9.8 we have on Earth, but where's the fun in that? This is a space opera. This is a different planet. Let's measure it. And figuring that these laser prison things are 3.75 meters tall, and knowing that Cal makes this 11.025 meter fall in 0.85 seconds, this gives us a wickedly strong gravity of 30.5 meters per second squared, 3 times Earth's gravity. Woohoo, doggy. Okay, let's pop that number into place. Density is an easy one. It's just the density of water, 997 kilograms per cubic meter. Now, depth. This one was tricky, and we'll circle back to it because we have one more thing to figure out. You see, this formula will give us pressure, which is fine, good, very helpful, but our pressure result will be in kilograms per square meter. That is a force over an area, and without an area, this gives us next to no insight into how much weight Vader is actually pushing back. We need to figure out the area of the front part of the water that he's shoving aside, and this is actually doable. It's this cross-section of the tunnel here filled with water. We're gonna simplify it just a little bit, but using these boxes as a reference and assuming that this thing is 2 isosceles trapezoids with bases of lengths 3.679 meters across the top plus 7.576 meters across the bottom, and a height 1 of 4.4 meters up to the top and a height 2 of 1 meter down to the bottom section, we can calculate their areas using the trapezoid area formula of 1/2 the sums of the bases times the height, and adding them together, bam! bam! We have 24.78 square meters. This is useful because we can actually use this tunnel to figure out how deep we are. Using Cheat Engine, we can enable the debug camera, and thank you so much for the work on that, Sunbeam. You are an actual lifesaver. Using the tunnel height, I can calculate how fast the camera moves straight up in debug mode, 10.568 meters per second. Then it's a simple issue of riding this camera from the tunnel here all the way up to the top of the water, which is... Okay, this is wrong because this angle is showing the fortress all the way underwater, but the cinematic shows a good chunk of it poking out above the water, so let's just assume that it's a developer shortcut since they never expected anybody to see this up close and just measure to that spot. And it took us 13.96 seconds to reach this spot exactly, giving us a depth of over 80 fathoms or 147 meters. You know what's really impressive about this? The deepest scuba dive on Earth was over 300 meters by Ahmad Gaber, and he experienced 324,383 kilograms per square meter of pressure. But it turns out that gravity makes a huge freaking difference. Under the 30.5 meters per second squared of gravity on Muir at a depth of 147 meters, the pressure is more like 4.5 million kilograms per square meter. And it's here where we get to finally plug this magic number into our calculator, hit enter, and hope that the world does not explode. And...
NANI?!
Vader is pushing 136.5 million kilograms away using the Force. You know what that equates to? The Titanic! Fully loaded with people and food and stuff. Actually, he wouldn't even break a sweat lifting the Titanic. Vader could deadlift the Titanic, Big Ben, the Washington Monument, 11 elephants, 50 grand pianos, 5 International Space Stations, and 10 fully fueled Antonov 255s at the same time, and still have enough Force strength left over to drink a cup of tea with the Force. Vader is a freaking beast. Do or do not, there is no try. Size means nothing. Freaking Yoda nearly had a heart attack lifting an X-Wing out of a swamp. Meanwhile, I'm reasonably certain Vader's over here making Starkiller look like an outclassed baby for struggling to just like barely push an Imperial Star Destroyer a little bit. This dude is strong in the Force in a legitimately terrifying way. Do not mess with Vader, and do not underestimate the power of water ever again. Sincerely, Austin.
They say there's something in the water.
Also, subscribe to the channel. You know it's not Banal. Oh, I stole that directly from Michael Swaim. He's a good boy. Anyway, subscribe to the channel. Dear LucasArts. Wait, you know what? No, this isn't the right way to do this. Bum 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 bum. Hi, it's me, Austin. I've been playing LucasArts games almost as long as I can remember, going all the way back to the dark ages of the 90s and the amazing point-and-click adventure game Indiana Jones and the Fate of Atlantis. Along with the masked renegade Zorro, Indiana Jones was my favorite hero as a child. You know, I also had a crush on Michelle Pfeiffer as Catwoman in Batman Returns. You know, that's a lot of whips. Probably was an early warning sign for my adulthood proclivities. Where was I? Oh, right, LucasArts. I love you guys. You and the rest of the expanded universe are single-handedly responsible for saving the Star Wars franchise during the crisis known as the prequel trilogy. Because of you guys and your good writing, you've managed to keep people interested in a franchise that was in danger of devolving into a pile of George Lucas's dried spunk. So for that, I thank you. Now that we've gotten this out of the way, I have to tell you something that's been bugging me for years. And that thing is this. Your lightsabers make no goddamn sense. And to be entirely fair, this isn't technically your fault. You didn't invent the things, but we are a video game channel, and so, I have to justify this rant somehow. When I was a kid, I always wanted a lightsaber. I imagined myself getting revenge on the dickheads in my science class who, for some reason, liked to validate their masculinity by throwing shit at the back of my head. I'd show them, pow, no more dicks for you, motherfuckers. But although I got older, realized my own inner sexiness, and stopped giving a shit about what mediocre, accomplished nothing suburban fuckheads thought, I never quite lost my love for these fantastic fantasy weapons. They're just damned cool. Of course, I'm soon to be a parent now, and I find myself becoming increasingly aware of everyday dangers that surround us, both real and fictional, and lightsabers are fucking dangerous. I never really appreciated this before. I thought of them as, glowy versions of the sticks me and my friends used to fake sword fight with. And you know what? Even those goddamn sticks are dangerous. I got gored more than once and hid what I'm pretty sure was a wound that needed stitches from my parents. I still have the scar, but no. Lightsabers are way, way worse than sticks, swords, and as you'll see in a little bit, maybe even goddamn guns. Let's back up for a second and rehash the lore of lightsabers. Lightsabers are flashlights that emit deadly as fuck beams of energy and are capable of cutting through just about anything under the sun, or under two suns as the case may or may not be. On a basic level, they're comprised of a few things: a power cell, a few focusing crystals, because this is goddamn space magic, you gotta have your fucking crystals, thingy-mabobbers, circuits, channels, and all kinds of shit. You flick a switch and energy does things, and okay, it's all bullshit, all right? It's all bullshit. Originally, in the back when times, they were attached to battery packs that were strapped to a Jedi's waist like ugly-ass fanny packs, but eventually they took on the modern, awesome form that we've become familiar with. And, of course, we got weird iterations like Darth Maul's saber staff, Kylo Ren's what the fuck thing, and at peak absurdities, lightsaber whips, because at some point, writers stopped giving a shit and just snorted all the coke in the room. Now, let's set one thing straight. Lightsabers are not actual swords made of light. That's what we call a laser, and they don't just magically stop at a certain length. They go on effectively forever. Plus, they don't behave like light either. They physically interact with surrounding materials, creating resistance for the wielder. This is not how light behaves. Now, the lore for lightsabers does indicate that the blades are massless, which is nonsense if they're not actually made of light. But, I'll buy that they're very, very light, if not actually massless. Modernity seems to have caught up with lightsaber technology, and everyone seems to be saying that the blades are made of plasma these days. And you know what? That's a brilliant choice. Plasma, as we've gone over many, many times on this channel, is a gas, or really any substance, that's been either heated up to an incredibly high temperature, compressed to an incredibly dense density, or a mix of the two to the point where the electrons start going berserk. Some atoms have more electrons than they should, others have less than they're supposed to. Cats and dogs are living together. It's mass hysteria in a plasma. As a result, these atoms get either a positive or a negative charge. In fact, it's this quality that gives lightsabers their first major feature, and is incidentally one of the first things we actually see a lightsaber do in Star Wars: deflection of blaster fire. Blasters, which also fire plasma, because I guess we're just gonna be as irresponsible as we can with materials capable of melting your face off, can be deflected by lightsabers. In theory, because they both carry the same magnetic charge. Have you ever tried to stick two magnetic ends together when they have the same charge? It doesn't work, they just push away. Unfortunately, we hit our first little snag here. For one, while atoms in the plasma state are totally ionized, not all the atoms in the plasma ionize with the same charge. In fact, while one atom loses an electron, it's likely that another atom will pick that up, either replacing the one that it's lost or giving it more than it's supposed to have. As a result, most plasmas as a whole have a neutral charge. Of course, even in our own world, we've had luck manipulating the magnetic fields of plasmas to be either primarily positive or primarily negative, but this doesn't exactly fix our problem. In order to deflect a plasma, it would definitely have to have the same charge as your lightsaber. If it were the opposite charge, it would actually get attracted to the blade, gaining velocity as it approached, and you'd risk it flying through the lightsaber entirely and smacking you in the face even faster than it would have if left alone. An easy counter to an ionized lightsaber would be to have a blaster that's capable of changing ionization at the flick of a switch. Meet the Jedi Slayer 9000! Are you a stormtrooper whose friends keep dying to pesky Jedi assholes who are sending your blaster bolts flying back at you? Pick up the Jedi Slayer 9000. The instant you see a Jedi starting to block your fire and send it back, just flick a switch and our handy dandy blaster will start alternating ionized states, turning that annoying person in a robe into a glowing flesh pile in minutes. And of course, if the lightsabers are neutrally charged, blaster bolts would just pass through them as though they weren't even there. Not exactly an ideal situation, but whatever. We've been over bolt deflection before. It's an awesome pony trick that, at the end of the day, is essentially made of bullshit. What about the good stuff? You know, like the cutting through anything like a hot knife through butter, severing arms, legs, heads, hands, and rendering even the most badass steel doors irrelevant? This is where lightsabers are not only fun as fuck, but totally fucking feasible. As opposed to being a single straight beam, lightsabers are actually a very narrow arc, so the material that's being heated up gets piped back into the lightsaber to be reheated. In theory, the plasma is contained and guided by a magnetic field, which, as I stated before, is a real phenomenon that we've seen in our real world. Now, while plasma seems fancy and science fiction-y, we actually use plasma all the time in our real world. It's in lights, TVs, and is even used to weld metals. That's right, plasma is used in our everyday world to cut through metal, just like Qui-Gon did in Phantom Menace. So, how hot would a lightsaber have to be in order to pull this off? Well, it depends. As I said before, lightsaber blades can't possibly be massless if they're plasma. They can, though, be light as hell. If we were to take, 100 grams of our favorite gas to turn into a plasma, hydrogen, the blade would weigh less than 2 Snickers bars. That's pretty damn light. Steel is kind of a bitch. It actually has a relatively low specific heat capacity, the amount of energy needed to heat it up, than lots of other materials, but it's very, very dense. The average lightsaber blade has a diameter of a little over 2.5 centimeters. So in order for it to melt through, say, a 1 foot thick steel door, we have to do a little bit of math. Doing this math, we discover the volume of the steel the lightsaber needs to penetrate, and knowing that, we just need to plug in a density of steel, and we get 1.2 kilograms just for a good old stabbing. The melting temperature of steel is over 1800 degrees Kelvin, and the specific heat is 0.49, which means that for every degree raised, it takes 0.49 joules per gram, but that's not enough. You see, anytime a substance undergoes a phase change, going from a solid to a liquid, or from a liquid to a gas, it requires a huge jump of energy to make that leap, which means that for every gram of steel, we need an extra 293 joules of energy. Damn it! Pushing all this shit together, we get 1.2 megajoules. All right, that's a lot, but, not ridiculous. In order to get this hot enough using our plasma sword weighing 100 grams, our blade would have to be heated up to a balmy 3000 degrees Kelvin. Awesome! Well, it's good to know that some things about this fantasy world aren't complete bullshit. Of course, well, this creates some problems, the least of which being that lightsabers at this temperature would effectively have no color at all and would be a blinding white light. Speaking of blinding, what we have here is effectively a plasma welding torch. Granted, a slightly cooler one than most because of the larger volume of hydrogen, but a torch nonetheless. And there's one thing you'll notice in all these movies, and all these video games, comics, and books, ain't nobody wearing protective eyewear. At these temperatures and masses, these blades are off-putting a staggering amount of ultraviolet light. Not enough to give you a sunburn, but way more than enough to burn your goddamn eyeballs to death if exposed for too long. And Jedi use these things all the fucking time. Their eyes should be practically useless, scabby husks of pus and sadness, not to mention that all those sparks you see everywhere aren't like the harmless sparks you get while using a sander against a piece of metal. They're straight up molten steel and metal. One of these tiny sparks is hot enough to sear through your clothing and give you a vicious 3rd-degree burn. This shit happens to real welders all the time. One slip up and a spark hits you where you're unprotected and your goddamn month is ruined. Lightsabers are way more dangerous to the person foolish enough to actually turn one on than they actually are to anybody wearing a white plastic helmet. So, no, I think I'm good living in a world where lightsabers aren't real. I don't want one anymore. They seem fucking terrible. Fuck. Now I see why folk are so hellbent on ridding the world of Jedi. They're probably just burning down buildings and causing rampant 3rd-degree burns everywhere they go. Fucking zealous assholes. Sincerely, Austin. P.S. I actually have a little bit of extra time. So, for funsies, let's do one more thing as a bonus. The Force Unleashed was supposed to be awesome. Instead, it was mediocre, and it completely upended pretty much everything established in the expanded universe and otherwise about how powerful the Force is. Yoda, one of the most powerful Force users in the galaxy, struggles to keep a tiny pillar upright, but Starkiller, a shithead with an even more annoying name, is capable of downing a goddamned Imperial-class Star Destroyer in the worst quick-time event known to man. Imperial Star Destroyers are 1,600 meters long and weigh over 6 million tons, aka an assload of kilograms. Using frames from the cinematic, we can see that the tip of the Star Destroyer hits the ground at a 20-degree angle. Using our trusty geometry, we discover that it travels a distance of almost 560 meters in 1.4 seconds at a speed of nearly 400 meters per second, which is faster than the speed of sound. The Star Destroyer experiences over 40 Gs of acceleration, which means that for a brief period of time, it has a weight force of over 232 billion kilograms, or half the mass of the entire human population. For that brief 1.4 seconds, it would be like if you took half the people on our planet and just plunked them down in one spot. The kinetic energy needed to move this behemoth is over 454 trillion joules, or the amount of fucking energy a goddamn hurricane releases in 4 seconds. God damn it, Starkiller is literally a fucking hurricane. And instead of, I don't know, just blowing up the engine with his apparently infinitely powerful force powers, he decided to be a complete shithead and just like throw it down like some sort of animal. What a fuckhead. Asshole. Thank you for watching my episode about Star Wars. This one's actually pretty requested. I liked it. This was a lot of fun. I have always loved the Star Wars universe, and I really love the most recent movie. I have not played Knights of the Old Republic as much as I probably should have. I know that makes me a terrible person, but it's true. I have played the Old Republic, or whatever the MMO was, and I also played the game that for some reason is 1,000,000 years old, and still no one has made a better lightsaber game than that, and that is Jedi Academy. I'm betting, this is past Austin, I'm betting I used a bunch of footage from that game in the video, but the video, how did they not get better at it? They've had years to make a better lightsaber game, and they can't. They suck at it. Thank you to our Patreon supporters who made this show possible with their incredible donations to our channel. They are awesome. And if you would like to be a Patreon supporter, you can go to our Patreon page at patreon.com/shoddycast, where you get all kinds of back behind the scenes action stuff. And you get, if you donate $3 a month, you actually get early access to videos like this one and ones like Andrew does in The Storyteller, of course. And I'm gonna go make this episode now. I built a lightsaber for it. I'm so excited. Woo! Oh yeah, and go watch me play Overwatch on Twitch. My tournament got postponed by a week because people are really bad about answering their emails. Oh, people, answer your emails. Emails. Who's got the emails? All right, bye. Dear Paradigm Games. Hi, it's me, Austin. Although to be honest, I'm not super sure if I want to address this video to Gray Still Plays instead of Paradigm Games, because honestly, I have been extremely, and I mean extremely tempted to fact check videos of his before. Not because he's done anything wrong, just because I'm a fan, and he plays games that are good to nitpick, and I'm a nitpicker. And like, how can I resist a game like Solar Smash, which lets you literally carve up the entire planet with a super powerful death ray? Oh, it is on like Donkey Kong! Okay, so for those of you who don't know, Solar Smash is a mobile game where you get to indulge your worst impulses in the form of a kid with a magnifying glass versus some ants. However, instead of a magnifying glass, it is Cthulhu, and instead of an anthill, it is an entire freaking planet. Plus, I've wanted to do a Death Star video for ages, so here we go! There's all sorts of things I could look at in Solar Smash, from the Cthulhu monster, the ghost punching guy, the missile swarm, and the laser that's able to carve the planet in half without destroying it somehow. But to keep it simple, we're gonna look at the Death Ray, the big baddie that's capable of destroying the planet entirely in one shot. Is this even possible? How would you do it if it were possible? And how many Duracell batteries would it take to power such a device? Two, my guess is two batteries. They're very good. Please sponsor me. Okay, so to get it out of the way first, exploding a planet is totally possible. How do I know this? Because suns can explode. Novae and supernovae and hypernovae all are things that explode out in the wider universe. If you put enough energy into anything at all, it will explode. Well, or turn into a black hole. I guess you can't really explode a black hole either, except I guess technically by Hawking radiation. But hey, did you know that there's a theoretical size limit to how big black holes can get? They're called ultra-massive black holes, which can get as big as 50 billion solar masses, which at this size, we're talking... Wait, okay, you know what? No, I'm not getting sidetracked talking about black holes. Maybe if this video does well, we'll do a video on Universe Sandbox. That'd be a pretty good excuse. Where was I? Oh, right. Put enough energy into anything and it'll explode. Boom. Okay, so how much energy do we need to put into a thing to make it explode? Well, it depends upon what you're trying to make blow up. In our case, we actually know what we're trying to explode. It is the entire Earth. In order to explode the Earth, you're gonna have to put enough energy into it to overcome the forces holding it together. When you explode like a firecracker or something, the energy released by the chemical bonds forming inside the firecracker heat up and expand, putting pressure on the thing containing it, a cardboard tube. In order to explode, it has to overcome the forces holding the tube together. Does that make sense? Same thing with the Earth, except the force that needs to be overcome is the force of gravity, as opposed to the molecular bonds between glue and pulverized wood fibers that make up the cardboard exterior of the firecracker. Essentially, you have to overcome the gravitational power holding the Earth together, and the rest will handle itself. And thankfully, there's actually a formula for calculating how much energy is holding the planet together, and it is really, really simple. It's just 3gm squared divided by 5r. Now, this formula looks simple on its face, but it's actually surprisingly complicated and requires many integrals and calculus, all of which simplify to this perfect, tiny little gem. 3 times the universal gravitational constant times the mass of the object squared divided by 5 times the radius. Mwah! When we plug in the values for the Earth, 6.3 million meters for the radius and 5.97 times 10 to the 24th power kilograms, we get a whopping result of 2.24 times 10 to the 32 joules of energy, or 223.9 billion yotta-joules, which is the bare minimum energy required to explodify the entire planet. For context, that's more energy than we get from the sun, like, ever. Seriously, that's 66.5 billion years worth of solar radiation that reaches us on our tiny little world. Given that the entire lifespan of our solar system is estimated to last a total of only like 10 billion years, suffice to say that this is a tremendously large amount of energy. But it's not an amount that you can't like get your head around. And in fact, the total actual output of the sun being 384.6 yottawatts, if we could somehow dunk the sun into water and let it spin up a turbine like a power plant, it'd take just shy of a week to generate the amount of energy we would need to power this death laser, or plasma beam. Honestly, at energies this huge, it's not even like it matters that much. The death beam in Solar Smash fires for, according to my calculations timing how long it takes the Earth to spin in place in the game and adjusting it to a realistic timescale, Sorry, I got sidetracked. The Earth in the game spins faster than the real Earth for aesthetic reasons, but don't worry your little head. I definitely accounted for that. Okay, so the beam fires for approximately 974 seconds, or just over 16 real-world minutes, adjusting for time scale, outputting 6 days worth of solar energy in that short amount of time, outputting 229.7 thousand yottawatts of power. Which, for the record, even if the Earth didn't explode, everything on it would definitely be dead, which is something you do see in the game. The instant the beam, laser, or whatever hit the atmosphere, everything it came into contact with would instantly become plasma, hotter than the core of the sun. The massive spike in heat would create a huge pressure wave that would move out from the point of impact, vaporizing nearby buildings and reverberating around the entire Earth. It wouldn't be like an atmosphere anymore. The pressure wave would be so dense and hit so hard that it would be like a wall of thick steel ripping around the globe, bulldozing everything in its path. Within minutes of first contact, there would not be a single living mammal on the surface of the planet. There might be some fish alive in the sea, but as soon as the pressure waves from the beam boring into the crust hit the ocean, boom! Sea life is dead too. Maybe some single cellular life may remain. It's not totally clear how pressure waves impact all of them, but within 5 minutes, there would be no more animal kingdom. As the beam pushes through the crust and closer to the core, earthquakes unlike anything that have ever been felt on this planet would rip through it like Taco Bell rips through my digestive tract, shattering entire mountains and filling canyons. Even after the beam was fired, the intense heat from the vaporized, and I quite literally mean vaporized, iron and nickel from our molten core would start to expand out, straining against its own gravity as the tremendously huge energy infused in the molecules keeps them moving too fast to care. It's entirely likely that the positron and electron pairs generated from this massive infusion of energy into our world would result in the obliteration of matter altogether, sending gamma and X-rays in all directions, causing even more havoc. Eventually, the pressures and energies reached would be too much, and gravity would become laughably insufficient to hold the planet together. I mean, we're talking 6 days of sun energy levels here. Gravity does not even enter the equation anymore. And like that, the Earth will be powderized, sending every particle that once made it up flying off into infinity forever. And for what it's worth, the beam in Solar Smash gets it kind of right. It's close. It's really close. Adjusted for real-life timescales, it does take a little too long for the Earth to explode, kind of funnily enough. But other than that, it's absolutely totally spot on to how it would actually happen. I have no idea how that little tiny alien spaceship the size of Florida manages to cram 6 days of the sun's total output into its interior, but I mean, it's technically possible. I mean, I calculated the mass equivalent of that amount of energy and got 2.49 times 10 to the 15 kilograms, which has a Schwarzschild radius of 0.0000000000037 meters. So it's not going to collapse into a black hole. So I'm going to label this one solidly plausible somehow. I don't know how, but it is technically. So yeah, little mobile game turns out to be surprisingly consistent with real world physics. No notes. A+. Oh, and I was way off on my estimate of 2 Duracell batteries by a lot. It would take only 23.8 octillion Duracell batteries to power this thing, so start saving up now and you'll have a death ray in only 20 billion years. Sincerely, Austin. I want to give a personal from the deepest, darkest corners of my recessed heart thanks to my patrons on Patreon: Matthew Ridge, Isby, Ronald Coleman, Alan Hagers, Edit MTP, Nicholas Spillinger, Marissa Resnick, and Loretta Mazurf. You guys make this show possible. I love you so much, and have a good one.